So that's part of the demo that I'm going to show you some live IoT.
Hold on one sec. Yeah.
The interoperability problem. Cool. Cool, thanks. So how does the unsexy industries like what you see on the screen here, how do they start their digital transformation journey if we listen to what Jim said in terms of journey? So what I'm going to show you today is how we turn IoT technology into operational capability and digital transformation, which is probably just a new word for business process reengineering, driven by a number of these different things that we see, and we can add blockchain and a number of other of those to it. One of the challenges that we see with Internet of Things, and Dr. Tim Chow at Stanford talks about the 3 problems of why IoT is not the Internet of People. First of all, there are just a lot of it. And as depending on which analyst you listen to, it'll grow. The other problem is that they just tell you so much more than people. So if you look at an oil rig, 30,000 sensors. By the way, less than 1% of the data is used. And on a day, you can collect 260 million data points. And the other problem that we have in IoT is that they consistently talk to you. So it's not just the volume. And we've come up with this word which we call IoT veracity, which is really sort of trying to encapsulate it. The other challenge that we face in IoT is that we have IT who owns some of the applications. We have OT who owns all these sensors, the operational technology, and then business who owns the problem. And if you think BPMS implementations are hard, try this. McKinsey came out with this IoT capability gap, and it really maps how we see customers go. Initially, they were struggling in how we connect sensors and data and build POCs and get started with that. Where they are, and where a lot of them are right now, it's around analytical modeling. How do we bring in AI? How do we manage these 260 million data points? And that's where a lot of them are at the journey now. But what they're realizing, and this was a key finding out of this McKinsey study, is that integrating this IoT technology into the existing business workflows, how does it change for a worker right on the oil rig or at the coalface? Cisco created this IoT World Reference Forum. I don't know why they're the World Reference Forum, but and again, it goes right from the device layer. And we've been solving many of these connectivity issues as we're going up. But right at the top, we now want to involve people in business. And the way that we approach that is that we need to ingest this data from historians, which is typically where a lot of this data goes, the sensors, web services, the business applications, contextual databases. So this is where a lot of it happens. What I'll be focusing most of my presentation is that yellow block. How do we pre-process that data so we can take Internet of Things data and make it Internet of People data? How do we find those exceptions? And inside that, we need to integrate, and we have to do a bunch of other things before we can pass it on to what we all know as the systems of transaction. And by the way, smart contracts are in here because we see that as a key thing in terms of supply chains, but also the BPM and custom development world. But what our customers really want is improved performance, revenue, new business models, reducing cost, and customer service. And Jim, I didn't have the slides in advance of what you were going to say, but we really connect real-time data to the analytics and the business process. And the way that we advise them is really start off with the problem, and then look at what algorithm or logic or analytic do I need, and then go and look if you have the data or the sensor. To put it in a slightly different context or slightly different view of it, we've got the data sources. We've got what we call active listening. So how can we listen for this real-time data, turn it into some data streams or data flows, and then have action agents that push it into the back. And what I'll be focusing most of my demo is around this middle part, where I show you how we connect IoT technology into the business process that sits on the other side. And again, it's all about the outcomes that the customers are trying to achieve. Quite often, customers refer to us as the glue that connect this real-time data to the analytics and the actions. And even though I'm going to show you in the industrial context, it applies to a broad range of other industries, including finance, banking, all of that. XMPro consists of a number of modules, and so the digital business platform core, we hope that thing emerges, but I'm going to focus mostly around streams and process. But if you look at the overall components of XMPro, that is what I'll be focusing on. And in the demo, what I'll be showing and focusing on is the use case manager, where we set up this, and then just what it looks like going from the Internet of Things to the Internet of People scenario. So with that, let me show you what I've been talking about. So I'm going to log in as Keith. And before we had all the people in the room, the internet was really fast. So hopefully, so I'll get back to this. This is sort of the portal view where a user would log in and see a bunch of data and do a bunch of things. But before I go there, I'm just going to go into what we call the IoT process monitor. And this is really a power user that we allow to set up these data flows. We find these power users are people like the engineers at the customer. They understand the problem, and they want to build some solution around it. Again, I'm doing this in an industrial context, but it applies to a broad range of different industries. So I'm going to go into the use case manager here and start off with a very basic example. So what you'll see here is we are trying, so these cooling towers are massive cooling towers that sit on refineries and places like that, where they, all the process materials after it's gone through, it cools down or it provides the cooling water for many of the industrial applications. These are massive fans. They can be 20 or 30 foot diameter. And if that goes down, my plant goes down. So this solves, if this goes down, it could be a couple of $1 million worth of problem. So what I'm doing in this instance, I'm bringing data in from a historian. In this instance, OSIsoft, which is quite it's used by the large majority of industry or organizations in that industry. I want to contextualize that data with make and model. So I want to know and I bring that in from an EAM system. It doesn't really matter which one. And I'll show you in a minute when I open this up how we configure that. I then combine the two data streams. The one is real-time data, so data in motion, data in rest. We combine the two. And then we call an analytic. We want to see if this is likely to fail, so we want to predict that. And if it's likely to fail, we want to create a work order inside EAM. So this is a very simple model, but it gives you a little bit of overview. In terms of, and what we find, and I love the slide that Neil had on with all the different systems and all the abundance. We're seeing a lot of abundance in those customers. We call them heterogeneous data sources. They just have a lot of them. And we've created this capability of an extensible library, so I can drag and drop my integration components on. Because in one instance, I might be using GE, I might be using OSIsoft. I might get it from SAP, our good friends, as Jim also spoke about them. So different places where you can get the data, and we can actively listen for that. We call them listeners. We can bring in context. So that was data in motion. This is data at rest. Whenever I want to bring in some of my context, and this is just a subset. This is an extensible library, so we can extend it, the customer can extend it, their partners can extend it, and we also have the concept of transformation. So how do I change this data by combining, filtering, doing things, broadcasting, and again, it's an extensible set of transformations. There might be some specific functions that they want to run. They want to run an R script, right? So they want to run some machine learning right there, or use something like a fast Fourier transformation where I'm getting 30,000 readings per second and I want to analyze what's happening to a bearing, for example. And then lastly, I want to create actions. And this is one of the key components of getting it back into the Internet of People, connecting it from the Internet of Things. And again, extensible, or quite a range of different ones. You can see we can push it into service management tools, back into the maintenance management system, or we can kick off a workflow. And we've got XMPro in here, but it could be any workflow tool that the customers already have. You'll see things like Slack and a number of them. So that is sort of the concept of having a library of extensible components, so active listeners, and then action agents. If I configure this, if I double-click on OS iSoft, this is where I set up the configuration. Now, one of the first things I want to do is set up the collection. The reason for this is we can push this down to the edge. Jim spoke about the edge. We can actually push the processing and have a very distributed environment. So the first part that you see over there could be at the edge. The middle part could be in the cloud. And the last part could be on-premise, because they have a on-premise installation of SAP. So this can be deployed, and the devices at the edge subscribe to this model. So we publish the model, and all these different devices, there could be tens of thousands that listen for, this is my configuration, and this is the current version of the configuration that I'm looking, or that I'm listening for. Setting up, and each of these stream objects, as we call them, have a different configuration set, but it's done so that the subject matter expert, the engineer at the customer, can actually connect, or as long as IT provides the governance framework and help and set up the governance framework, I, as the engineer, can actually set up my own stream, because I understand the business problem that I'm trying to solve in this case. So that's a very basic one. And this is kind of, if you look at this is RPA in a different fashion. The challenge that we have is that not everyone wants to automatically create that work order. They don't trust artificial intelligence. They still want to have that human interaction in the middle. So if I look at a slightly, or at a different version of this, actual fact, I'm first going to go here, and then I'll show you the sort of what customers really deploy when they look at this. This is what we call a demonstrator, and we have some of these units that we put with customers who are looking at and trying to explain internally how some of this works. And I'll just expand this so you can see a little bit better. But this is it's got a centrifugal pump, it's got a PLC, all the stuff that the engineers love. It gives them data. It goes to a gateway, aka PC on the side. And for the sales guys in the room, it has big buttons. So I can start the motors, I can simulate vibration, I can simulate temperature, and we get that information in. So that's the flow that we're setting up here. So for that, we need OPC UI connector, which is a slightly different one. So if I configure that, it's got its own configuration pane that looks different, and I'm bringing back the vibration and temperature, as you can see. So you can again do and by the way, if you double click on the arrow, that's how we do the mapping. If I want to run a predictive model, in this instance, I bring the Macon model, I combine it with the OPC data. And again, this could be any real-time data stream in your business. It could be web clicks, it could be anything. It doesn't have to be industrial data, as long as it's fast, real, because we're taking big data, trying to turn it into smart data before it hits the business process. The smart data component, we all talk about machine learning. How do we do that? In this instance, we have and this is running on Azure Machine Learning. So it calls the Azure model, passes our API key, and I get a result back. So that is really how you implement something or bring in AI into. Now that's not all customers are there. Some of them just want to do a filter, for example. So in this instance, I'm taking the temperature and vibration data. I'm checking if I'm above a certain vibration threshold. If I am, I want to call my first predictive model. Is this thing going to fail? And these guys have been doing it for a long time. They know how to build those models. If it's going to fail, how much time do I have? So I want to run a second model, which is called a remaining useful life model. And that then tells me I have 200 hours. So now I have the information that I can pass on to Internet of People, and we can start scheduling work. What I can also do is send out an SMS, but based on some of the talks this morning, one of the other action agents is we can actually start having, a conversation with the chatbot. So we've got examples where the pump actually comes alive on my Skype, and it tells me, I'm pump so-and-so, I'm not feeling well, I'm going to break. And it's done all the logic that you've seen in here, because it's collected all the information as it goes down the stream, and it gets to the point where it says, I'm going to break down in so many hours, you don't have spares, and can I get the technician from the customer on the line to you? That is the kind of interactions that we build real time with these things. But for our more conservative customers, we can still send you an SMS. And then the last part is, as I said earlier, people don't like it when you just start creating work orders in their back-end systems, in the EAM system, whatever. They don't trust the situation yet. They don't want 1,000 work orders that suddenly appear from nowhere. So what we do there is we pass it on to a BPM tool, BPM capability. And I'll show you what that looks like as well. So going back to that capability, so I'm now in the BPM side, and I'm just going to, and I'm not going to spend too much time because everyone in this room knows how BPM works. This is the XMPro BPM capability. I'm just going to look at my actions. I'm logged in as Keith, and I have a few things to do, and most of my stuff's in red because I haven't attended to it yet. But I'm just going to open up that, so we can pass the parameters. What I didn't show in here is we can pass the parameters to the XMPro configuration. So it's going to kick off a certain BPM workflow, and it's going to pass me, so I want to have that one, and it's going to pass me the information through to my task over here. So on this task, this is a normal BPM pane. You can go and customize, and like all iBPMS or BPMS or whatever tools you're using, or case management or whatever it is, this is more of a case style because I can choose what I want to do. And our biggest reason for doing this, we need to provide decision support to that engineer. It's not about taking the action. We just want to give them as much information as we can for them to decide, am I going to approve this work order, am I going to discard it, and why would I discard it? So one of the things that we do, that same predictive model that we ran earlier, I can run it again, or I can just bring the value. So remaining useful life is 198 hours. I can bring in data from my, and again, this is all standard BPM capability for everyone in the room, but I can bring data from my SAP instance around how much space do I have, because this is all important to me to make the decision on what to do next. What other work orders are currently open? Are we working on machines right next to it or upstream? Can I shut that? Can I schedule it so that I have that pit stop mentality like we have in racing? We can bring in some of the other information that's available. One of the things that people always like to see is how can we bring in pretty pictures? So if I have that pump, I'll just load it in. So we've got the capability on the BPM side to actually bring in, and I'm just going to explode the pump a little bit. And I can see that's the part I'm having a problem with. Now this is, again, you can put it back onto a mobile device for the technician, and with AR and VR and everything that comes in, this is all stuff that you can do with that. But the key part and the biggest value proposition is actually how do we take this 260 million data points that I collect on my oil rig and find the 5 or 6 jobs that needs to be done in order to make sure that this thing doesn't go down, that I'm not losing tens of millions of dollars a day. And that's the logic and the flow that we have with that. One last thing I just want to show. So I showed you the basic version of what it looks like. When we work with customers, this is more the pattern that emerges around, again, reading real-time data, real-time input, applying analytics, and same analytics. And this could be a local, at the edge, PMML model that we're running. Or it could be Azure, it could be Watson if you're getting into the cognitive side and getting, so anywhere you are, but we find most customers are very low on that maturity scale at the moment. There are customers who've got large teams of hundreds of data scientists. They are getting there fast. So for those of you that think AI is coming, it is here. It is just the finding vehicles to put it in. And again, that's our focus. How do we provide a vehicle for the analytics? In remaining useful life, the other interesting thing that we see some advanced organizations do is they actually have an optimization algorithm that they run to go and find, now that I know that I have 200 hours, what is the optimum maintenance slot to go and do that based on all the other moving parts? There are organizations that run these algorithms every 15 minutes to optimize across their work orders, production schedules, and that. And then lastly, create failure mode analysis again in the BPM workflow side of things, push it through to analytical dashboards, and here check for spares and also amend work orders, create work orders. So this is more the real pattern of deployment that we see with customers. So with that, what I've tried to show you is how you can connect real-time data, this IoT thing, and again, this is an industrial example, but it applies to many others. Be interesting to see how we can listen for GDPR data. Just thought of it as the discussions went around the table. How do we bring in analytics, simple or complex, and how do we create the actions that come out of it to turn IoT technology into operational capability? Thank you. Any questions?
Just one, it's a very naive question. I noticed that a lot of your data in motion was picked by a poll approach.
Yeah.
Is there other modes that
Yes,
are
so there are push modes. So there are certain protocols like MQTT or those where you have a channel and you subscribe to that channel so we can listen to the real-time data. We're finding a lot of, in industrial environments where they have old data systems, we have to mimic that. We say we poll every 10 seconds or every 1 second or every 5 seconds, but the best scenario is where you have, you then need to decide when you combine the data at rest with that data in motion, how quickly you want to do that. That's just one or the other.
And I'm assuming it would make sense to take some of these transform, push it to the edge as concentrators, and then poll these concentrators as opposed to...
Yes. We also have the concept of being able to call one of these events. So we can create a very simple version of this event stream, push it right to the edge, let that collection of devices subscribe to that, and that is then consumed into a new, bigger one where we're only listening for the exceptions. Because we want to do as much processing at the edge and run some as much as so we're basically pushing the process to the edge there. Thank you. Good question.
So what was the step where you bring the make and model of the equipment?
Yeah.
How do you do the exceptions? Like if that fails, what happens with the exception?
So what you typically find, and the difference between a transactional approach where and basically operational intelligence where we're trying to just react to real-time things. So you can decide if you're going to stop the process, if you can't do something, or do we just discard that record and listen for the next one and trying to context and trying to get the context again. Because the difference between this and sort of a BI approach is BI you want to store and then go and analyze later as much as you can. This is data streaming at me, I'm analyzing and maybe I store some of it. Sometimes there are So some of the transformations that we have are to clean data. So I remove all things that have got null in or whatever. So you can do some of that as well. But to cleanse the data as it comes through, if you have there are two types of issues. One that will cause a break in the whole logic. The other one is just there's a blip in that sensor. It's not on. It's not sending me anything. Ignore it. Wait for the next one. Because that's the premise of real-time operational intelligence versus business intelligence, which says I've got all of this. And just by the way, business intelligence gives us a good place to go and find where we want to put in the real-time things. But, Bruce.
How do you keep up with data that's coming too fast?
You scale the horsepower at the back, because this is really an orchestration engine. It runs on infrastructure like Azure, AWS, or whatever, when you're in the cloud. So when you get to, there are certain, so when you are looking at the individual devices, it could be running Linux on a very low power device, but then we only have a small component and it only does one dedicated thing. When you start bringing all of that together, that's when you need to really look at balancing the flow in terms of where the horsepower sits behind it, and that's where we consume.
So that will work on average, or but there's still going to be bursts where you're overwhelmed with the data, right?
It depends on the use case. There might be instances where you have a massive volume of data coming at you, and then you decide, do I want to handle all of them, or do I want to pick some of them discard the rest, because that's the benefit that we have. We don't have to process everything, especially if we're trying to put analytics or something on top of that, some of the real-time analytics. We can try and analyze the volume that we can do, run it through models or filters or whatever the case might be to go and try and find that needle in the haystack. But yeah, and that's why we came up with the word veracity, because we actually see there's a new word in IoT. There's just this massive volume of data. And those are some of the things that, in terms of scalability, that you need to design into. That and trustworthiness are the two things you need to design into. There was another question.
Well, I mean, this is just to continue with Bruce's thing, is I understand the transformations for cleaning up the data, potentially clearing out the data volume at that point, but there is an ingest point in your orchestration engine. I think Bruce is asking, like, how do you scale or handle the intensity volume there before even getting to the transformation or filter stage?
Again, when we look at the ingestion points and where they are deployed, if you're going to read from 10,000 sensors, what you don't want to do is do 30,000 readings per second from 10,000 sensors, because that's not even our problem. That's a network problem if you want to move that kind of data. So you need to really design around that use cases and then start with, what is the problem that I'm really trying to solve? So don't start with, I have all these sensors. And we have customers that sort of start with, we have all these sensors, it's got 30,000, what can you do with it? Really need to look at that use case. But there are instances where if you get to those extremes where you are going to do that, you need to really design for that use case and make sure that you put the horsepower where you're going to need it from a processing capability. So whether it's memory-based processing or physical processing or whatever the case might be. But yeah, that's all part of the design. That, and again, as I said, trustworthiness are the two main things that you need to design for in this.